Heads up, this is pretty detailed stuff. As mentioned in part 2, I had a few glitches when sketching the shaft grabber clip. The solver complained with the usual cryptic orange messages, but the sketch did indicate fully constrained and padded as expected. I don't like errors and warnings when creating models, so I dug a bit deeper into the problem. The shaft grabber sketch is a simple set of radial arms with a split at the top to allow movement. Another split at the bottom is used for an attachment boss. Initially, I created 2 concentric circles, figuring I could split the inner one at the top and the outer one at the top and bottom. The inner circle split fine with the trim edge tool. The outer circle generated funky errors when I attempted to split it in 2 places. Messages like duplicate geometry and redundant constraints popped out. Near as I can tell, split circles are converted to arcs. These behave in unexpected ways when split twice. The solution was to use arcs to begin with, which created natural gaps top and bottom. That said, managing the constraints is a bit tricky to avoid errors. This video shows how I created an error-free closed sketch that's fully constrained. I've included a link to step-by-step instructions and the completed model. This model is an update to the one linked in the Part 2 video. Okay, as I had mentioned earlier, the Part 2 video model had a little glitch in the shaft grabber. So I spent a little time and I got that fixed. So what I'm going to do in this video to keep it manageable is go through just the sketch for the shaft grabber. It's a little tricky, but it's not that hard once you see it. So this is the model that's actually workable and correct from Part 2. So what I'm going to do is I'm going to go in and I'm going to delete this pad right here, and I'm going to delete this sketch. So that knocks out the shaft grabber, and we'll turn off the cylinder. Let's turn off the cylinder, and we'll turn off the datum plane. We don't need to see that. We'll select the XY plane, and we'll go into the sketcher. So what I did was I created a PDF, which is linked in the description for that. There's a lot of steps involved with this. It's real hard to remember what's going on, but I'll go through this so you can see how this works, and you can print out that PDF and work through it yourself. So step number 1 is to create a circle with its center at the origin. So we'll do that right there. And just a heads up, sometimes the point of the geometry isn't always coincident with the origin. So you can fix that by selecting both points and then go up here and do this constrained coincident. It's probably a superfluous effort here, but if you find that circles or arcs are moving around, we can check that. That's probably the reason. That I've seen that happen on occasion. So what we'll do is the spreadsheet and everything is all in place, so we're just going to go ahead and give this a constraint. So we'll go ahead here and go up, and what we want is we want a diameter constraint on this. So we'll go up here and we want to pick the spreadsheet value, so that will be spreadsheet.j2 is what that is. So that's that. So we got that set up. We'll cancel the tool. Let's zoom in a little bit right there so we can see that. So the next thing we want to do is draw 2 lines up here. This is going to start to form the basis of the gap for the grabber arms. So we'll just draw these in. As it turns out, these 2 lines just worked out to be constrained vertically, which is what we want. They may or may not do that, so you want to make sure that they both are vertical lines. In addition to that, what we want to do is we want to make these equal. So we'll do that, give them an equal constraint, and then we also want to make these lines symmetric about the y-axis. We want them to sit right in the middle. So we'll select here, Control select here, and then Control select here, and give that a symmetry constraint. Be advised that the order that you select these in matters, so you have to select the 2 points on the outside and then select the symmetry axis as the last thing. So we got that, and then what we'll do is we'll give these lines a distance. So we'll go here, select, control, click, select. We want to give this a horizontal distance. We'll make it 1 millimeter. That usually works pretty well. We'll pretty this up a little bit so we can see it. So we'll just sort of leave that as is. And then we want to draw the attachment boss, which is going to be a 3-sided box. We want to do that down here at 6 o'clock. So we can just go here to the polyline tool, just go down here and just draw this in. So again, these lines just happen to work out. They're both vertical and and this one here is horizontal. So that's important. We want to make sure that we achieve that. So just check that. If that doesn't happen, then you're going to have to give the sides a vertical constraint. We also want to make these sides equal. So we'll cancel the tool, we'll select here, and we'll make these equal. So we want to do that. And then we'll also want to make this 3-sided box symmetrical about the y-axis. So we'll do that like we did on the top. Give that a symmetry constraint right there. That's good. And then we want to draw now a center arc so that it intersects the top and the bottom. But before we do that, let's go ahead and give some length to these lines. So this one here, we can go ahead and give that a length of 3.5 millimeters. I find that works pretty well. We can do that. And then down here on the bottom, we can give that a horizontal length. I chose 8 millimeters. That works pretty well. It's a nice fat boss. It gives it strength that it needs. So the next thing we want to do now is we want to draw a center arc. So we can do that. We just pick this tool right here, and we want to make sure we get on the center. And make sure that comes around. So we do that, and we want to give this a radius. So we'll go ahead here, and in this constraint we'll want to do this auto radius right here. So we'll go ahead and select that, and again what we're going to do is we're going to pull a value from the spreadsheet. So that's spreadsheet dot J2. We've got to add a little bit of thickness for the arms, and then since it's a radius, we want to take that whole quantity and divide it by 2. So that takes care of that. And we want to make sure that there's intersections between these vertical lines and these vertical lines. So what we can do here, we can kind of pull this up a little bit right there. It's good enough. That's a good way to leave that. So we can do that, and then we want to go ahead and draw another arc on the other side. So we'll go ahead, just select that tool. Want to make that about the same radius. So we'll bring it around, bring it right there. And then what we want to do now is we want to make this and this, we want to give that an equal constraint. So we've got that going on there. Now the important thing, like I said before, is to make sure these circles our arcs are pinned to the center. So we go ahead here, we can try to move this, and it's not going to move. We want to go over here and try to move this. It's not going to move. So that means its center is pinned right to the origin. That's important. So that's, just check that if you need to, if you need to. And what we want to do now is knock out this bit of arc in here. So we can go over here to the trim edge, and we can just go ahead here, and that splits that circle right there. And what we can do next is we go ahead and make this point and this point. Make sure it gets selected. Let's try again. This point and this point, make that coincident. So that's good. And then we can go up here, do the same thing. Select these 2 points. I'm on a mouse pad, so it's not exactly all that fine. Make that coincident. Same thing on this side. Make that coincident right there. So now you're starting to see this take shape. We've got the arms in there. Now we've got to deal with the bottom. So what we'll do here is we'll take this point and make that coincident. And what's important here to avoid errors is to knock out this equal constraint. We want to delete that. And then we'll go ahead and make this point and this point coincident right there. Voila, there we go. So that sketch is fully constrained. There's our grabber arms. This area down here is our boss, which is going to penetrate the knob body. And these dimensions are hard-coded. Like I said, they work generally pretty well, but you can tweak these if you need to. And these dimensions here are coming off the spreadsheet for the shaft diameter and what's allowed for the thickness of the arm. I made it 2 millimeters, and I experimented with a bunch of different prints, and I found 2 millimeters gives these enough strength so they grab the shaft but not too rigid. So what we can do next is we just go ahead, close this out, and we can go ahead here and turn this back on. The last thing we need to do here is we want to go ahead and pad this out. So let's do that. So we'll go ahead up here, select pad. This 10 millimeters is out of control, so that wants to be spreadsheet dot K2, which is the shaft length. We want to make sure that we give it a little bit smaller pad than what the shaft depth is, so that what happens here is that the top of these arms don't get welded to the interior of the knob. So we're good there. So 1/2 millimeter is what I used. It works pretty well. So we go ahead and now take a bottom view of this knob, give it a slight angle here. So there it is. There's the boss that beds into the body of the knob. Here's your grabber arms, which will flex open to accommodate a 6 millimeter shaft, and then there's this little gap here that allows that to happen. So this is what I figured out, and just quickly to repeat again, the circles that get cut, if you try to cut them in 2 spots, they convert to arcs, and I don't know, things get weird, and the solver starts spitting out kind of cryptic messages. So I found that if I use the techniques that I just went through, you get a clean sketch, it fully constrains, and you don't get any errors. So that's the story with this. It's kind of a nice little knob for projects and low torque applications. You can play around with the design parameters in the spreadsheet. Be advised again that the spreadsheet doesn't do any checks, so if you put in crazy numbers, the model can blow up. But if you just use some common sense and you keep things within limits and perspective, things should work out pretty well. So I hope this video was helpful, and we'll see you next time.